Okay, 6.6. We're going to talk about trapezoids and kites today, but first, let's review over rhombi and squares. I'm assuming we all understand this because we all finished the warm-up really quickly today. All right, so this first one is a rhombus, which means all the sides are congruent. That's one thing. It means the diagonals are what? Do you remember? Yep, bisect each other, as do all parallelograms. What else? Perpendicular, yep. So cross at a right angle. And yes, they still bisect each other since it's a parallelogram. So those would be congruent, and these would be as well. The other thing we know is that the diagonals do what to the angles?
Oh, they bisect.
Bisect the angles. Nice, Alejandro. So I know like this diagonal HF would be split into two congruent angles. And then what do I know about opposite angles in all parallelograms? Congruent. So this would split it into the same two congruent angles. Okay, that's properties with my rhombi. Same with this diagonal. Let's split these into two congruent angles. All that information just based upon that first statement, that it's a rhombus. Okay, so let's go through our criteria here, what they want us to find. JG. This is based off of what Gwen said, that the diagonals would be bisected. So that would also be 24. Next one they want me to find is FJ. FJ is right here. FJ. So looking at this, I see I have a right triangle. I have this distance, I'm going to call it X, but I'm trying to find, I have this leg, and then I have 25 as my hypotenuse, so you should have used Pythag to find this. 24 squared, my leg squared, should equal my hypotenuse squared. All right, so that's what, 576? That's 625. Subtract that over. You get 49. Square root both sides. 7. So you check for that distance, that length. Okay, I like that. Now they're asking me for some angle measures. EFH. EFH. Okay, kind of already talked through this, and I marked it on here. EFH would be this angle, and I said that would be congruent. So that one over there, so that should also be 62 degrees. Two reasons. Bisect and opposite angles are congruent. Last one. HGE. HGE. There's a couple ways you could figure this out. I see this as one little triangle. And I know it's a right triangle. So for me, the easiest way to do this would be 180 minus 90 minus 62 to figure out this angle. Which was 28. 28. Yep, 28. That could be one way. Another way you could have done it is I know that the sum of all the interior angles in any quadrilateral and any four-sided polygon have to add to what? What are you going to say? 360. 360, yep, because you can form two triangles, right? Look at this. That has a total 180. That has a total 180. Okay, so I know they also have to always total 360. So you could have done, well, I have 62, 62, 62, 62, add those all up, subtract it from 360, divide that by 2 to get these angles, and then divide those by 2 to see where it bisects. Did anybody do that? No, you guys all did it the same way I did, right? You saw a little triangle? Yeah, okay. That's a review over my rhombi. We also talked about squares. So a parallelogram that's a rectangle and a rhombus is a square. So with squares, they got a lot going on. They have 4 right angles. They have 4 congruent sides. Their diagonals are still bisected because it's a parallelogram, so that's going to be congruent to that. And like a rectangle, the diagonals are congruent. So these are also going to be all 7. And like a rhombus, the diagonals are perpendicular. That's all my characteristics we kind of talked about with squares. All right, so first criteria they want me to find is JL, so this whole length of the diagonal. Now, based off what I just told you, all the diagonals are bisected and congruent, so those are also going to be 7. So what would JL be, folks? 14. Yep, bless you. 14. Ooh, ML. How would I go about finding ML? Ideas. Alejandro? Okay. We don't know it's 7. Oh, I see what you're saying. Yeah, sorry. I should have done like I see what you're saying, like this. Yeah. Okay, sorry. That's my bad. Pythag, because this is a right angle. And I know my 2 legs are 7, so I just need to find the hypotenuse. Okay, good catch. I'm going to call it X again. So this time, my 2 legs squared would be 7 and 7, and my hypotenuse is my unknown. So 49 and 49 is 98. Square root it. All right, square root of 98. Simplified, obviously that's 49 times 2, so that'd be 7 root 2. If you have a decimal, if you wrote it as a decimal, that's fine, but it doesn't specify if they want you to leave it in simplest radical form or not. That's just a more exact answer. Which means that's the length of all of these sides. Okay. Measure of angle KNL. Where is KNL? Oh, I already marked that. KNL would be how many degrees? 90. Diagonals are perpendicular. Last one, measure of angle MKJ. This little one right here. Ooh, how'd you know that so quickly? Who said that? Siler? How'd you know it was 45 degrees? You're right. Exactly, like a rhombus. It also bisects. The diagonals bisect the angles, and we knew it was a right angle. Good job. Okay, there's a little review over our characteristics of rhombi and squares, and you still have the book assignment to do for tomorrow. That's covers that lesson as well. All right, so our last lesson of chapter 6, folks. Whoop, whoop. Which means there's a test coming soon. I don't know exactly when it is yet. I haven't decided. It's either going to be next week, Wednesday, or Thursday. Wednesday. Because we don't have school Friday.
Do we have a quiz?
We do have one more quiz yet. So that's either going to be Monday or Tuesday, depending on what I decide to do. All right, so our last 2 types of quadrilaterals we have to talk about, and we will finish filling out our family tree. Right? We have all members now. We're going to talk about trapezoids, my personal favorite. Trapezoids. And kites. Kites are kind of cool too, but not that cool. Okay. All right. Let's start with trapezoids. Trapezoids are quadrilaterals that have exactly and only one parallel sides that are opposite. Opposite parallel sides, probably be a better way to say it. Only one. All right, so looking at this photo here, you can see, I'm going to trace these in green. These 2 are my parallel sides. And the other 2 sides cannot be parallel. Otherwise, it's a parallelogram. Okay? So trapezoid, not a type of parallelogram. It's its own category, as are kites. You'll see it in the tree. So trapezoid, exactly one pair of parallel sides, which we call bases. The pair of non-parallel sides we call legs. All right, I'm going to label this trapezoid A, B, C, D. So we call like angle A and angle B, or 2 angles that lie on the same base. we call them a pair of like base angles. So A and B we call base angles. And so would C and D. They could be classified as a pair of base angles because they're lying on the opposite base, but the same one. Okay. Here's kind of a cool characteristic with trapezoids. One reason why I love them. You don't have to write this down. You can if you want, but just look up here for a second. If I extend these parallel lines a little bit, this angle right here, we'll call it angle D. And if I were to extend this leg, you could almost think of that leg as like a transversal of my two parallel bases here. Okay, can you kind of see that? The green ones are the two parallel lines, and then here's my transversal. This angle would be congruent to this angle up here. Why? I think you mouthed it. What'd you say? Corresponding angles, right? Corresponding angles. And these two have to add to what? 180, or I think I heard you say consecutive interior. Did you say that?
I accidentally said that and then meant corresponding.
Okay, that's okay. These two would be considered consecutive interior, meaning they have to add up to what? 180. That's another way you can think of it. Or think this would be the same as this, and these are supplementary, so these would also be supplementary. Okay? So that's another characteristic that here, angle A and angle D are supplementary. Now they have to lie on like the two opposite parallel bases. So I don't want to say the consecutive angles are supplementary because technically like A and B are consecutive next to each other, but those are not supplementary. Okay, so they have to lie on like the two opposite parallel lines. And if you think of it like a transversal, that's why I guess they're
call them non-base angles. Just the
consecutive non-base angles.
Yeah.
Yeah, you can see that probably. So B and D would also be supplementary. Same reason. Okay, there's one characteristic with trapezoids. Now, we have a special type of trapezoids that are called isosceles trapezoids that are very similar to isosceles triangles. So isosceles trapezoids, still a trapezoid because I have parallel bases. And when the legs, which are the two non-parallel sides, when the legs are the same length, aka congruent, then we call this an isosceles trapezoid. So it literally almost looks like it's an isosceles triangle, but instead of having 3 sides, we have 4 sides, and these two opposite sides are my bases and they're parallel. That's an isosceles trapezoid. There's a lot of cool things that happen in an isosceles trapezoid. That's what we're going to talk about next. Okay. First characteristic of an isosceles trapezoid. Kind of like the isosceles triangle theorem. This is the isosceles triangle theorem. If these two sides are congruent, then their opposite angles are also congruent, right? Or vice versa. We can use that in the converse. That if these two angles are congruent, the two sides across from it are going to be the same length, aka it's going to be isosceles triangle. So an isosceles trapezoid, if we know it's isosceles, meaning the legs are congruent, then each pair of base angles, or you can think kind of the ones across, or you can go this way, those angles are going to be congruent, the base angles. All right, so if trapezoid is isosceles, then in this case, a pair of base angles would be G and H and F and J would be congruent. G and F would still be supplementary. Okay, you could still think of that leg as a transversal. Consecutive interior angles. But those angles would be congruent. Only in isosceles, only if the two legs are congruent, okay? All right, next thing about isosceles. Oh, this is basically just the converse. So if you know these angles are congruent, a pair of base angles, doesn't matter which one, like let's say this one, if we know that angle L is congruent to angle M, okay, then we know this side and this side are congruent, making this an isosceles trapezoid. Then trapezoid is isosceles. Okay, last one. If a trapezoid is isosceles, its diagonals are congruent. Now notice how the statement says if and only if. I like this. If and only if means this and the converse are true. Okay, and that's kind of what I put down here. So if the diagonals are congruent, then it's an isosceles trapezoid, and vice versa. If it's an isosceles trapezoid, then you can also conclude the diagonals are congruent. Okay. So if in this case the diagonals are congruent, so the diagonals would be like the opposite vertices, like QS. If that's congruent to RT, those are the same length, then the trapezoid is isosceles. And then I just kind of put down here, that's what that if and only if means. It means the converse would also be true. If you know the trapezoid is isosceles, then the diagonals are congruent. Oh my gosh, there's so many characteristics and properties. Maybe we need like a little spreadsheet of all these. That'd be fun. Okay, so those are isosceles trapezoid. Let's try a practice problem with an isosceles trapezoid. So you have this basket. Each side of the basket shown is an isosceles trapezoid. Okay, so you can look here. I know it's a trapezoid because it looks like this. ML is parallel to JK. And since it's an isosceles trapezoid, that means my two legs are congruent. So JM would be congruent to KL. All right, here's what they're given to us. JML is 130 degrees. So this angle right here is 130 degrees. KN is 6.7 feet. And LN is 3.6 feet. Find the measure of angle MJK and JL. All right, I'll just start with this one, MJK. MJK is right here. Couple ways you could do this. First, since this is an isosceles trapezoid, if this angle is 130, what is this base angle also going to be? 130. The base angles are congruent. So we could calculate, all right, these add up to 260. I know the total interior angles have to add up to 360. 360 minus 260 is 100. And I know these also have to be congruent because it's an isosceles trapezoid, meaning I get 50. That's one way you could do it. Or I think an easier way is in all trapezoids, isosceles included, these angles, think of them as consecutive interior angles, total 180. All right, so another way you could do it is that 130 degrees plus this one. And all those have to add to 180. So you can get 50 as well. However you want to do that. Just know the first way I did that with like adding them together, telling to 360, that would only work if it was isosceles because otherwise we wouldn't know these base angles are congruent. All right, JL. This diagonal right here, JL. All right, we know the diagonals are congruent. So I know this little piece is 3.6. again, I know the diagonals are congruent because this is an isosceles triangle. So I know that this is going to be the same length as well. If this is 6.7, this is going to be 6.7. So that total JL would just be 6.7 plus 3.6 because those diagonals are congruent. So it's at 10.3 feet. Okay. Ooh, I like the next one. I graphed this quadrilateral for you this time. They want us to show that ABCD is a trapezoid. And then they want us to determine whether it is an isosceles trapezoid. Okay. So in order for it to be a trapezoid, in order to show that, we just have to show that one pair of opposite sides are parallel. All right? So that's what I'm going to do first. Show it's a trapezoid by proving one pair of opposite sides not congruent, parallel. That's my characteristic with trapezoid. All right, so here's what I'm going to let you do. I'm going to let you use a little bit of like visual common sense here. And instead of just calculating the slope of all four sides, what two look like they could be the parallel sides? C, D, and BA, right? These two. So pick the ones that look parallel, and if you can show me they are parallel, you're good, okay? So CD, let's calculate that slope. Rise over run, I go up 1 over 4 in the positive direction. BA, up 2 over 8, which reduces to 1/4. So are those parallel? Yes, same slope. Okay, let's mark that. These are parallel. So there's me showing it's a trapezoid. I have one pair of parallel sides, and obviously just by using a little common sense, the other sides don't look parallel, so we're good. How would I determine if this is an isosceles trapezoid? Ideas. You.
Find the
I'm gonna call you you. Sorry, that was rude. Ben.
Find the distance of C, B, and D, A.
Find the length of the legs. If those are the same distance or the same length, then that's an isosceles trapezoid. Another idea. That's how I did it. Yes.
Find the diagonals.
Find the diagonal length. You could also do this. CA and BD. And if the diagonal lengths are congruent, then it will be an isosceles trapezoid. Somebody said that last hour too, so I had Isaac Henkel. He did that. He calculated the diagonals, and we calculated the legs. So you could do either. Show legs or diagonals are congruent. If yes, then it's an isosceles trapezoid. Okay, I personally did the legs. So for CB, I got the distance to be the square root of 17. And for AD, I got that distance to be the square root of 18, which is 3 root 2. Simplified. And then, I don't remember exactly what Isaac got when he calculated the diagonal lengths, but I remember he said, they're not the same. I'm getting two different distances. And I was like, okay, so are we. So if the legs are not the same length, or the diagonals are not the same length, this would not be an isosceles trapezoid. Yes, sir. Oh, you did the diagonals?
Square root of 15 and square root of 53.
Square root of 15 and square root of 53?
50, yeah.
Oh, that makes more sense. Okay, 15, 53. Good. Either way, not the same. Okay, so it's a trapezoid, ABCD. But not isosceles. because you can either say the diagonals are not congruent or the legs are not congruent. So I'm going to say AD is not congruent to CD. Okay. One other property with trapezoids. There's so many exciting things with trapezoids. We have something called a mid-segment in a trapezoid. All right, let's break down what that is. A mid-segment finds the midpoint of each leg. All right, so look at this picture here. AF and CD are my bases because those are parallel. So my two legs would be AC and FD. So if I find the midpoint of each of those, which that's what they're showing you right here. So the midpoint of AC is B and the midpoint of FD is E. And if I connect those, that's called the mid-segment. Connects. Midpoints of legs. All right, here's some properties with the mid-segment. If we know it's a mid-segment, it's gonna have to be parallel to the other two bases. Okay, that's one characteristic. So the mid-segment BE would be parallel to AF, and BE is going to be parallel to CD, the other base. It's going to be parallel to both bases. And here's the cool part. The length of the mid-segment is the average of the lengths of the bases. So whatever this length is, plus whatever this length is, how do I calculate the average? I would divide that by 2, and that's going to be the exact distance of the mid-segment. Okay, so to put it in a little formula for you, BE is always going to be half the distance of whatever the sum of the bases distances are, or the lengths. Okay, that's another way to calculate the average. Half of the distance, half of the length. Isn't that cool?
Yes.
Okay. Now this one, I'm sure a lot of you number sense people could kind of logic your way through this one. So they're telling us that MN is the mid-segment of this trapezoid. So you guys could probably figure out 20 plus what would give me an average of 30. Okay, I get that. But they're not always going to be that nice, easy of numbers. So this is kind of a way you can set up an equation, if you will. I know that this base KF plus this base JG, which I'm calling X, I know that if I average those, it has to equal the length of this mid-segment. Okay, so let's plug in what we know. This is 30. KF is 20. And again, even from here, I'm sure a lot of you could figure out that it's going to be 40, right? But let's go through how we solve this equation with fractions. Anyways, because you guys need practice. I would not distribute the 1/2. I would instead get rid of the 1/2 by timesing both sides by 2, because 2 times 1/2 is 1. That essentially just like undoes that layer around your variable. So we get 60 equals 20 plus x. So that base has to be 40. Again, these are pretty nice numbers, and you're like, Centrich, I know 30 is the average of 20 and 40. Yeah, that's great. Good number sense. But if the numbers get harder, use that as an example to solve it. All right, we're going to talk a little bit about kites. I know we don't have a ton of time, but it's okay. We're going to start our discussion about kites. So kites are not parallelograms. They're also their own category, okay? A kite is a type of a quadrilateral, but no parallel sides. Here's their characteristics. Their consecutive sides are congruent. So this side and this side, I should say a pair of consecutive congruent sides and a second pair of consecutive congruent sides. So look like that. That's what it's saying here. Exactly 2 pairs of consecutive sides are congruent. So note, the opposite sides are not congruent, nor are they parallel. Okay, that's what a kite is. Here's my characteristics with kites. Similar to rhombi, the diagonals are perpendicular. So if we know it's a kite, then we know the diagonals are perpendicular. So in that diagram over there, one of my diagonals, AC, would be perpendicular to BD. Okay, that's one characteristic with kites. Ooh, this one's cool. If it's a kite, there's exactly 1 pair of opposite angles that are congruent. All right? So, how we know which angles are congruent is they have to be formed by 2 different lengths of sides, is a good way to put it. So in this example, since JK is congruent to KL, that's what they're showing you right here, and JM is congruent to ML, that's what they're showing you here. The 2 congruent angles would be J and L, not K and M. Okay, here's why. Do you see how these angles are formed by 2 different lengths of sides? That's always going to be the pair of congruent angles. It's always going to be the angles that are formed by the non-congruent side. But do you see how angle K is formed by the 1 hash mark sides, the 2 congruent sides, and so is this one? So those ones are not going to be congruent that are formed by the same length of sides. So I just maybe write this down. It's always the pair between non-congruent sides. Are the pair of congruent angles. All right, so we're just going to do one problem, and then I'm going to pass out the worksheet. We'll save the rest for tomorrow. So it's always the pair between the non-congruent sides. So look at this one. They're telling us it's a kite. Find the measure of angle X, Y, Z. So this one right here. So if you're tempted to say 73, that thinking is wrong. Because 73 is formed by 2 congruent sides. So I got to look for the angle that's formed by 2 non-congruent sides, which is 121. And that's going to be congruent to the other angle formed by 2 non-congruent sides, which would be angle Z. That'd be 121. So what Lillian said, all quadrilaterals have an interior angle sum of 360. We could easily figure out what this one is by adding up these. So I'm just going to double 120 plus 73 plus XYZ. That should total 360. All right, this sum right here is already 315 degrees. So that missing angle would have to be 45 degrees. Okay, that's exactly where my other class got to too, actually. This is perfect. Let me pass out the worksheet, but